I haven't done it myself, but I was like, I should have brought my cell phone to see if, because then you can also record and do a slow motion and actually see
and
the track.
capture the
So from a cloud chamber like this, and the YouTube movie that I posted in Evernote, you can already tell quite some interesting aspects of the type of radiations that we can see. What they all have in common is that they are charged particles. Typically, those will be, as I said, electrons, muons, and alpha particles. What's interesting though is that electrons, which there's quite a few squiggly ones, are likely electrons, but electron radiation typically will not penetrate this box. So where the muons really could not care less about much material and they'll go through it, electrons are really coming from processes that generate beta decay or electrons inside this box. And like I said, radon gas is one candidate. You can tell more about the tracks by looking at them. If you look careful enough, you see differences in the intensity of the tracks. Can you give me an idea? What do you think intuitively the difference in intensity tells me?
The higher charge.
the speed particle travel.
So the charge is one thing, right? I mean, more ionization. But if these are, and there's not much alpha sources here, so this is mostly electrons. If you presume these are all electrons, I think one of you just said it. It's not only charge, it is velocity. So what do you think a bright track versus a not so bright track? Which one of the two is the faster one, you think?
The bright track carries stronger momentum.
The bright one you think is a stronger momentum?
Wait, no, the slower it travels, the
exactly.
more
It's a slower one that leaves a brighter track. It has more time to interact with the material. The fast one really is going so fast that it has just less opportunity to interact.
What does that say about types of particle? Or
You mean, well,
like
the
can you identify particle like from the velocity?
So I can say that muons, for example, who are a lot heavier than electrons, you will not see much difference in the intensity of the light of the trails. Electrons, on the other hand, are have a wider spectrum because they interact more with the other particles. They leave, and what's really cool is when you stare at this for a longer time, you'll probably also will see that these electrons, like I said before, have, that was a crazy one. You see, it has like a hook, which means that clearly it encountered something that an interaction, much like what we usually draw in sort of diagrams. But that's really what happens, and there's another one. See,
What do they collide with again?
the very particles, whatever alcohol, but just
Anything inside it.
yeah.
So the longer ones mean it's coming at an angle, and the
Yeah.
shorter ones is like.
That's the thing, but if I was able to completely fill this up with, and that's obviously not possible because I want it to be warm here, then I would see tracks that go like this. But that's a bit hard now. So sometimes you see these very long tracks. Those really are